Hey, this is Mr. Gilman. Today we are going to solve and graph inequalities. So what we've been doing in the past is equalities. Now we're going to move on to inequalities. So greater thans or less thans or greater than or equal to's or less than or equal to's. All right. This is very, very, very important. And on your PSAEs and on your main tests, all your standardized tests, they like to throw this on there to see if you know what you're doing or not. If you multiply or divide, it has to be multiply or divide, an inequality by a negative number, the inequality changes direction. Okay? If you multiply or divide, it has to be multiply or divide. It doesn't matter if you add or subtract, that's okay. But if you multiply or divide by a negative number, the direction of the inequality will change sides. So let me show you kind of what I mean here. If I have this little equation here, and it says negative 3x equals 9. Okay? If I want to solve that, we all know now that this says negative 3 times x equals 9. The opposite of multiply is divide, so I will divide both sides by negative 3. The difference today is, okay, when you get x equals negative 3, the difference today is it's going to be the same idea, but it's going to be negative 3x is less than 9. And so we're still trying to get x all alone, but when we divide both sides by this negative 3 here, nothing ever happens to an equal sign, but in an inequality, the sign, instead of being a less than sign, is now going to be a greater than sign. Okay, and that's what that rule says. If you multiply or divide by a negative, you change the direction of the sign. Okay, so this is exactly what we're doing today. All your problems look exactly like this, okay? What we want to do is we want to solve and graph each inequality. Okay, so what we've learned is when it says solve, you want the variable on one side, everything else, all the numbers and variables on the other side. So in this first problem here, what we're trying to get all by itself is k. We always want to add or subtract first, multiply or divide second. I can use subtraction to get rid of this 3. It says plus 3, the opposite of addition is subtraction. So if I minus 3 from both sides, I know the 3's will cancel out, and all I'm left with is k. And I didn't multiply or divide by negative, so the sign stays the same. Only when you multiply or divide does it change. And then finally on the right hand side, negative 4 minus 3 is negative 7. Alright, and so what I'm going to do is I'm going to go over here to my number line. I'm going to extend it a little bit. Negative 6, negative 7, and just like the other day when we were graphing these, I have a greater than or equal to, so I'm going to put a closed dot on my graph, and I want all the values bigger than negative 7. Okay, if you want to remember the little trick, you can put a little arrow in there, and I want this side, so I'm going to draw my arrow in. I want the right side towards the positive numbers. Okay, and so essentially it's exactly like what we've done in the past, except for it's an inequality. So let's look at the next one here. Once again, I want to get the variable all by itself. So what I'm going to do is I'm going to subtract 3 again. I always add or subtract first, multiply or divide second. So I'm going to subtract 3 from both sides. The reason I did that was to cancel out that 3. I just want this x all by himself. So now that I don't have any 3's left, I'm left with a 2x. The sign didn't change because I didn't multiply or divide by a negative. 9 minus 3 is 6. So this is my new equation, a new inequality. Now it says 2 times x is less than or equal to 6, but we don't want the 2, we just want the x. The opposite of multiply is divide. So because this is 2 times x, I'm going to divide both sides by 2. So I know x must be less than or equal to 3. Okay, the reason I did not change the sign is because I didn't divide by a negative. I did divide, but I did not divide by a negative. It has to be a negative if you're going to flip the sign. Now, if I want to graph this thing, now that I've got x all by itself, I've solved for x. I need a closed dot again on 3. I want all the values to the left of that. And if you can't remember which way to point your arrow, okay, I want the side that's less than 3, or you can draw a little arrow in there. Okay, and there's all the values to the left of 3. Okay, so the first step you have to do is solve for the variable, and then once you have the variable, you just graph it just like what we've been doing in the past. Okay, let me show you a common mistake students like to make. Okay, they get to their quiz and they say, okay, well, all I got to worry about is the greater than sign and the -4. So what they do is they just go right to the number line and they start at -4 and they draw the arrow in to the right. If you don't solve for the variable first, that's not going to be the same solution. So just keep this in mind as we work. We're going to see, will we get the same solution if we do it by solving for the variable first? Let's find out. If I want to solve for s, okay, I need to add or subtract first to get rid of anything I can do with addition and subtraction. Then I need to multiply or divide next. This is a -1. The opposite of subtraction is addition, so I'm going to add 1 to both sides. S over 3 is greater than -4 plus 1, which is -3. So I'm a little closer to solving for s now. The next thing I need to do, because it says s divided by 3, the opposite of divide would be multiply. So if I want to get rid of this 3, I'm going to multiply this side by 3 and the right hand side by 3. Alright, and the reason we did that, we know because the opposite of divide is multiply that these will cancel out. And so all we have left is s. And because we didn't multiply by a negative, we just multiplied by a positive, the sign doesn't change. So we're just going to go ahead and keep it as a greater than sign. -3 times 3 is -9. So we're going to go over to our number line here, and once again we're going to have to extend it a little bit. So I'm going to just go ahead and draw them in a little bit more. There's -9, I'm going to say. And I'm going to graph it the same way as we have in the past. Now remember, just less than or greater thans, they get open dots. Alright, so I'm going to put an open dot on -9. I'm going to draw my arrow in here. It's going to go to the right this time. Okay, or what I want is really all the values bigger than -9. And I know all positive numbers are bigger than negative numbers, so I'm going to go towards the positive numbers. So as you can see, if you just go ahead and graph it right off at the beginning, it's going to be a little different on your number line than if you solve first and then graph it. So make sure you always solve for the variable first. Let's look at this last one here. And now it says -3n minus 5 is less than 1. So what I need to do is this. I need to add or subtract first to get rid of any numbers I can. I want to get n by itself. And I know if I add 5 to both sides, that will cancel out a -5. So I'm going to add 5 to both sides. I knew these were going to cancel out. That's why I added 5. So now I have -3n is less than 6. I'm almost there. The last thing I need to do is divide. It says -3 times n. If I divide both sides by -3, I know that n will be greater than -2. As you can see, I divided by a negative, and that's when you flip the sign. Okay, on all the other ones, the sign stayed the same all the way through. On this one, we divided by a negative number. That's when you know to flip the sign. It was a less than sign. Now it's a greater than sign. Okay, and so now we're just going to graph it the same way we always do. We're going to go to -2. We know it's going to be an open dot. I'm going to put an open dot on -2. I want all the values bigger than -2, so I can draw my little arrow in here. Okay, n is greater than -2, so I'm going to go ahead and draw that little arrow in there. And so my solution is right here, -2 on the graph, and all the numbers bigger than that. Okay, this is my other solution that I'm looking for on your homework. All right, and that's what we're doing today. So we're just solving equations, but we're graphing our solution.